Okay, welcome everyone to this quick NanoFrazor setup video. In this video I will show you how to quickly set up your tool, so TSPL and laser configuration, and TSPL and laser patterning in a way that will be the way I would use the machine, and in a way that hopefully should be fast and effective for everyone using the tool. So let's get it started by clicking on our NanoFrazor software icon. This procedure usually of loading takes around 30 seconds. So let's wait until our NanoFrazor software is ready. Okay, we're here. We're using a NanoFrazor Explorer. So we have TSPL laser. So first thing we have to do is setting our user. So we call ourselves NanoFrazor user, and we put our sample. It's 10% PPA on silicon, and let's also put our cantilever batch, which is a 2022-01. If we want to load user settings that we created in the past, we can load it here. So load settings. But in case we're good with standard settings, we can just set it export folder, and then we have the green light in the setup. As mentioned in introduction videos, usually we operate the software from left to right. So when we are done with the setup, we can move towards the TSPL config. Good, we're here. First of all, before starting the configuration, we want to focus our camera on the surface of our sample. So in this case, I'm using a NanoFrazor Explorer, so I can control the focus motor from the software. Well, if you are using a NanoFrazor Scholar, you have to manually adjust the focus on the surface. If you're always using the same kind of samples, this procedure should also not be always useful, because I assume that you will always have the good focus if your samples are consistent. So let's also approach the surface with our cantilever manually. So usually when I turn off the machine, or when we do this exchange cantilever procedure, we move up by 2 millimeters. So now I slowly approach the surface by moving down first by 1.5 millimeter, and then I can move down by steps of 100 micrometers. Once I see the shape of the cantilever, which is more and more in focus, so now we're quite close, maybe I can move down by 50. Okay, at this point we are good to go with our TSPL configuration. Good to go means that the approach piezo procedure, which is in the advanced tools, is going to take a little bit shorter time. Even if you're not if you don't see the cantilever very well focused, you can still do the TSPL configuration. Just this reader sensitivity calibration is going to take longer, because we will do a step-by-step extension of the piezo along the Z direction. So if you're 1 or 2 millimeters away from the surface, this procedure is just going to take longer, so around 5 to 10 minutes maybe. Again, just to repeat, during this TSPL config we will run an IV calibration to check the reader and the writer conditions. We do an approach piezo to find the surface and to check the quality of our tip and the sample level plane. So we have a green light also for the TSPL setup. Let's move towards the laser configuration. If we press play, we will run all these 4 procedures. So let's press play and see if we're successfully able to configure the laser. In case you don't have a NanoFrazor Explorer, so you have a NanoFrazor Scholar, you can skip this process. And what's important to remember is that during the first step of the laser configuration, we also do the camera autofocus procedure, where we find also the tip of our on our cantilever image. So you will see once we have the green light, we will have this fine tip position that's successful, hopefully. Like also the software asks us, is a tip found correctly, and say yes, and then we can move towards the next procedure, which is the tip laser offset. So in case you don't have this autofocus, you have to manually set the position of the tip from here, or you can also use in the utilities this fine tip position. So now we are doing the third operation of the laser config, so the detection of the cross pattern. We still do not see the cross pattern. So we let this procedure run again. Now we see something that looks more like a cross, but still not really a cross, so we still say no. This looks a bit nicer, but maybe the next step will be a little bit better. You can still say no, maybe we get a nicer cross and then run the next procedure. Okay, so now we see a nice cross. Yes. And now we can start with the laser focus operation. It's important to remember that when we do the laser configuration, we can change all the power, pixel time, and pixel size. And it's important to keep in mind also whether we have a good efficiency of writing with the laser. So these parameters can be adjusted in case you see that you don't have a very effective or successful laser configuration. In this case, we see that we are able to write very efficiently. Actually, probably we're writing too deep for this laser focus operation, but it should be already good enough to find a good focus for the laser. To calculate the efficiency of the laser for your specific stack and the effective power on the surface, you can use the optional tools. So the laser power calibration to calculate the effective power, and the efficiency calculator for your specific stuff, which depend on the materials that you're using. So here we see that probably we're writing a little bit too deep. So the dots that are reported in this topography are merging with one another. Ideally, we don't want to see this merging of the dots, so we could use a lower power, or also decrease the exposure times, for example. Hopefully the software will still be able to find the dots and associate the best focus. So in this case, we found the focus at 9 micrometers. So we're happy with the green light. In case you're always using the same samples, you can just set the laser focus position from here at 9, because ideally it should not change much if you always have the same thickness of your silicon substrate, for example. But you can also change the laser focus position afterwards to also save some time. So yes, we have the laser config done, TSPL config done. We can move towards the geometry to import two geometry, one for the TSPL. We can do a 3D lithography. We import a sine wave. Let's check this white pixel so that we have a continuous sine wave. We can also see the 3D view. So quite a nice view of our pattern. We import it as TSPL, and then we also want to import a narrow. for the laser. So in this case, we don't want to write white pixels. For the laser, now we want a larger pixel size because it's not really needed to have 20 nanometers because the laser spot is much larger than the dimension of the tip at its apex. So we can change also the laser power. So we can put 100, and we see that we have quite a nice arrow. We can make it maybe a little bit larger, 1.3 times larger. If we press scale, and in order to remove these sort of imperfections that are caused by the file that we are importing, we can select 2D so that we are only patterning with the same power, which is 100. We're happy. We can import this geometry as laser layout, and then we can move towards the session in the warm-up. Here we see our two layouts. So let's move a little bit with the stage. And let's do first our TSPL layout. So when we turn on the software for the first time, the feedback doesn't really know which are a good set of parameters to use for the specific pattern. So usually we do a test pattern to find good parameters, and then we can do an official pattern, let's say, that has the best starting forces. So let's now start the patterning. We see that in the last converged state, basically we don't have any last converged state. So we will just try to pattern with some forces, and then the feedback will try to optimize these forces so that the target depth will match with the measured depth. So now we're not really able to pattern, so hopefully the feedback will try to increase the force. We see already that the feedback is working quite well, and now we are already having a very nice sine wave. We can also add some corrections, the fast-scan corrections or the Bowen correction after the feedback has converged. That maybe can give us even better results of patterning, but this is already a very good grayscale patterning, so we're matching quite well our sine wave. We don't really have to let the test run for a very long time, or at least until the whole field is completed, because once the feedback has converged, then we can already stop this test pattern and pattern somewhere else using the last converged state of the feedback. So now we pattern again the same field, but using the last converged state. So we will not see this initial adjustment of the feedback, because the feedback already knows which are good starting good writing forces to start writing our grayscale lithography. And we can see this live, so with the depth of the initial fields, which is already quite good. So yeah, we can let it run, and this will be the fastest setup for our nanofraser. For a grayscale lithography, for a 2D lithography, it's even easier, because the feedback usually has to work even less. You can also write without feedback if you already know good forces for your specific samples and specific stack that you have. So you should be able to effectively pattern anything in this way. it may require sometimes some adjustments of parameters if you see that you struggle writing, but now we are doing just a basics setup for the most common sample that we will have, which is just some PPA on silicon. So we have a very nice sine wave. We can also see our 3D view. It looks very, very nice. We're quite happy about it. And yeah, we can move to the laser. Our nice arrow. And if we press play, we see that it only takes 23 seconds. We can press also play from here. In this case, you see that some information like the laser effective power here is grayed out. If you want to do a complete setup of the laser, you may also want to do the laser power calibration, which is described in one of the videos regarding the laser configuration tab. But in this case we didn't do it. You can also preload laser power calibration that you did already, because it's always good to know the effective power that we have on our sample. But you see that we have patterned our nice arrow with the laser, quite large area for the TSPL in a very short time. So yeah, this is it, I will say, because we have successfully patterned with our TSPL, our 3D or grayscale lithography, and with the laser our arrow. And this is how I would set up the tool for common substrates in a very fast and efficient way. I hope this could help in setting up your nanophasor tool as well.